A conversion graph is a graphical representation of a linear model. Okay, so we've seen linear models in the past expressed, in the form y equals mx plus c, or if it's a direct linear variation model, y equals kx, or in that form. What are they used for? It's used for quick conversion. Okay, so where accuracy is not the most important thing, but you just want a quick indication of converting between one unit or another, a conversion graph is very useful for that. So as an example, or some examples, we could be looking at unit conversions, such as converting between metric and imperial. So for example, degrees Celsius to degrees Fahrenheit, or vice versa, or between miles and kilometers, kilograms and pounds, or maybe converting between two currencies. So converting between, say, US dollars and Australian dollars. Okay, let's have a look at an example. Okay, and I've actually drawn a graph to assist with this example. Actually, you're going to need it to be able to answer this one. So the graph shown converts between miles and kilometers. So this is the graph. Okay. So we have miles here on the y-axis, kilometers on the x-axis, and our line, or our conversion line, is this red line here, is what's going to be used to help convert between one unit or another. Yeah, let's have a look at the questions. So I'm going to smudge the ink. There we go. So convert the following distances to miles. So we have 30, 15, and 50. Okay. So let's look at 30 kilometers first. Okay, you'll need a ruler for this. Okay, so what we do, 30 kilometers. Okay, so mark out where it is on the x-axis, because that's what the x-axis represents. Okay, and okay, if we just draw a line, a vertical line, okay, and where it crosses, or where it intersects with the red line, okay, okay, we then mark a line across. Okay, thereabouts. Okay, so I'll just zoom in on that. There we go. Okay, so that's probably the closest, more close to 11, 12, 13, 14, 15, 16, 17, 18. It's around 18.5, isn't it? Or thereabouts. Okay, so 30 kilometers, okay, is 18.5 miles. And you could, look, it doesn't have to be exact. You could have put 18.4 or 18.6. Probably wouldn't matter too much, as long as you're sort of in the vicinity. That's the main thing. So what about 15 kilometers? So I'd expect 15 kilometers to be obviously half of 18.5. Let's see if that's in fact the case. Okay, so 15 kilometers. Okay, so where's that? 11, 12, 13, 14, there's 15 there. Okay. There we go. Okay. And then we project across to the y-axis. Okay. All right, reading that, that's about 9.2, thereabouts. Okay. Again, it doesn't have to be exact. So we'll work this out to be around 9.2 miles. Okay. And what about 50 kilometers? Okay, so we go to the other end of the x-axis. Okay, there's 50 kilometers there. Okay. And projecting upwards. Okay. And projecting across. Okay. And that looks like it's right on 31 miles. Okay. The unit for miles, we can use MI. That's one of the units that we can use. Some countries would use M, but we don't want to confuse that with meters. So we'll use MI here. All right, let's have a look at part B. It says convert the following distances to kilometers. So now we're going the other way, 28 miles. Okay, so let's locate 28 miles on the y-axis. 10, that's 20 there. 21, 22, 23, 24, 26, 27, there's 28. Okay, or we can count back from 30, either way. There's our 28 mile mark. Okay. Okay, we're going to project across. And then project down to the x-axis. Okay. And that looks like 41, 42, 43, that looks like 45. Okay, so it's like 45 kilometers. Okay, 28 miles is around 45 kilometers. Okay, 17 miles. Okay. Again, we're just doing the same thing. So 17, so 20, 19, 18, there's 17. Yep. Okay, 17 miles, projecting across. Okay. So again, what's important is where it crosses the red line. Okay, so it crosses around there. Okay, so let's project downward to the x-axis. Okay, and where's that? So that's 30, 29, 28, there's 27. It's about 27.3, thereabouts, 27.3. Yep. And then we've got 10 miles. Okay. So there's 10 miles there. Okay. And projecting downwards. Okay. And that looks to be like around 16 kilometers. Okay, so our last part C, what is the conversion rate in miles per kilometer? Okay. So we can use our conversion chart for this. So what this really is asking for is something that's related to the gradient of the line somehow. So what we do know, we pick a point, pick a very convenient point. Okay, so I might pick this point here. Okay, because it happens to be, at least according to this graph, that 50 kilometers, okay, equals 31 miles. Okay. Or 31 miles equals 50 kilometers. Okay. So expressed as a rate, okay, that's 31 miles per 50 kilometers, but we want it as a rate per kilometer. Okay, so we need to divide both of those terms by 50. So I don't want a rate per 50 kilometers, I want a rate per kilometer. Okay. So 31 divided by 50, and we get 0.62. miles per kilometer. Okay, and just while we're on the topic of conversion, what about kilometers per mile? So I might just add this one as an extra. What about kilometers per mile? So reversing those around. So if 50 kilometers, okay, per 31 miles. We want it in kilometres per mile. We need to divide both of these by 31. Okay, so we work with rates. We usually want the second term to be a unit, to be 1. So 50 divided by 31, and we get 1.61. So it's around 1.61 kilometers per mile, and that's roughly around what the conversion is, in fact, if you look it up. Okay. Thanks for watching, everyone, and wishing you all the best for your studies.